This is the beginning of lesson 4 from unit 12, and we are solving trigonometric functions. Now, we already started with this in lesson 1, and so we are just going to add to that. There's no reason to write down example 1, but I do want you to watch it. So we are provided with this equation we're told to solve. What we're not told is how many solutions do we have to state. So when you see a sine function or a cosine function, when you see a sine function or cosine function, and you're going to graph it by hand, how long is the period? I call it period length. It's often represented with just the word period. How long is sine and cosine? 2 pi. If you didn't know that, you should write that down. Make sure your earbuds are out, please. You need to know that today. Sine and cosine have a period length of 2 pi. What, as well as the reciprocal functions, what we call the secondary trig functions. What about tangent? Pi. Tangent and cotangent have a period length of pi. So when we see this problem and we're going to solve it, which I trust all of you can do, when we're solving this and it doesn't say, it just says solve. It doesn't say like how many solutions are we supposed to state. We will first of all state what are the solutions when we just do one revolution, which would be 2 pi because we're working with a sine function. But then we have to make a general rule that we recognize that sine functions, cosine functions, right, they're waves. So it's ongoing, and so we need to make a general rule for the solution. So that's what this is about, this example. So I add 1, again, you're not writing this part down, I add 1, perfect, I divide by 2, awesome. Now this is a good review. I don't want you right now, I want you to take that paper that I'm going to show you really quick. I want you to take this, and I want you to flip it upside down. And I want you to, you don't have to put it away, just flip it upside down. I want you to turn to your partner. Where is the sign equal to positive 1/2? Turn to your partner, go. Where is the sign equal to positive 1/2? So cosine before sine, right? So sine is our second one. Here's where sine is equal to 1/2. Now it's a positive 1/2. So all-star trig class, that means in this location we have a positive sign of 1/2, and in this location we also have. So let's flip that paper over and let's just make sure that is correct. See, we have a positive 1/2 here, we have a positive 1/2 here. So we could say at this point that we have solutions at pi over 6 and 5 pi over 6. The next thing, and I apologize, either I'm getting a cold or allergies, we need to write a general rule. So when we think about turning this into an equation, y equals this, and we graph this, right, and we see the sine curve, what would be the general rule for the solutions? And here's what we would have. This is the important part that I want you to write down as an example, what I am putting down right now. So I have the solution that occurs on the interval. There's the interval, okay? This is the solution for this particular function. But we know the sine curve is ongoing, and so a general solution would look like this. I would like you to have these down because we're going to apply that when we talk about general rules. Okay, moving forward, let's look now at example number 2. I'm going to give you a chance to write it down, and as you're doing that, you don't need to answer out loud, but what is the period length of a sine? What is the period length of a sine? Again, a sine and a cosine, period length is 2 pi. And so it says find the solutions on the interval. It is specific, right? It is specific about where we are going to identify the solutions. So how do we go about doing this? What can we do? We are going to collect terms or combine like terms. So I'm going to add sine to the opposite side, plus sine, plus sine. These are additive inverses, they equal 0. Now I have 2 sine of x plus radical 2. I'm going to subtract radical 2 to the opposite side. 2 sine of x equals negative radical 2. Divide by 2. I know I'm writing really quick. And now I have the sine of x equals negative radical 2 over 2. I'm going to press pause on this video for those that are watching this in playback, and I want to give you 30 seconds to finish writing this down, and then without looking at the cheat sheet, and the cheat sheet I'm referring to is this, I want you to locate on the interval provided to us, where do we find these solutions? I'm going to provide you with 30 seconds. All right, and while kids are talking, again, I'm making this quick circle, and I just know this is 1, 2, 3, 1, 2, 3. Okay, so sine is in the second area, but then when I have to think about all, star, trig, class, where are sines negative? They're located in these two positions. So you're right here and right here. So 1 over 4, 2, 3, 4, 5. So I believe that we have answers here at x equals 5 pi over 4, 6, and 7 pi over 4. Always feel free to raise your hand if you disagree with me or you are confused. Can I have hands raised if you agree with my answers? Hands raised? Okay, we're going to move on right now to, moving on right now to example number 3. I'm going to give you a chance to write it down. And as you're writing it down, I want to remind us, what is the period length of tangents and its reciprocal? 1 pi. Perfect, 1 pi. Now, why is that important? Because in this problem, it simply says solve. And it didn't give us an interval. So we have to recognize that the interval for tangents is, again, from 0 to pi. So I'm going to write that down right now. We're going to go 0 to pi. Okay. If you have not started, we are now going to use algebra as we solve this. I'm dividing by 3. I have tangent squared x equals 1/3. How do I remove the square? I take the square root, but I'm going to have two answers. Tangent of x equals plus or minus the square root of 1 over the square root of 3. I'm going to write off to the side so it's easier for you to see. I know the square root of 1 is 1 and the square root of 3 is irrational. Nothing's wrong with this, but it's not a proper way to write it down. So I'm going to multiply both the top and bottom by the square root of 3. That gives me 1 times the square root of 3 is the square root of 3. Square root of 3 times the square root of 3 is square root of 9, which in turn simplifies to 3. So I have the tangent of x equals plus or minus square root of 3 over 3. Do not look at the cheat sheet. How are you now beginning to remember tangents? Now that's a little bit harder, but we haven't spent a lot of time that we look back to our cheat sheet. So I want you to turn to your partner right now without looking at the cheat sheet. Have you started to memorize what they are? I'm going to talk about with you in 30 seconds. Right, so without looking at your cheat sheet, I'm going to come back over here, please. Remember, we only have to memorize the first quadrant, and then we can apply it to quadrant 2, 3, and 4 because we recognize how the angles are all related. So the easiest one to memorize is the 45. That's a 1. Now, I remember that, you can just pull a chair right next to Josh, please. I remember there's less on top here. So this is radical 3, and this is radical 3 over 3. At this point, it is undefined, and over here, it's going to be zeros at these points. So this is 0, 0, this is undefined. So I remember there's less on top than there is in the bottom, and this is the easy one for me. Remember that tangent is sine divided by cosine. They're the exact same values. That's how we get a 1. Now, how does that help us for this problem? So I recognize that it's here. So when I think about an entire unit circle, these are the different positions that have this exact tangent, except for we know all star trig class, we want both positives and negatives would give us solutions at each one of these. Now, here's where the mistake is made. If you put down all 4 of these, which would be 1 pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. The problem is you are forgetting that we are working with tangent. And what is the period length for tangent? It's 1 pi. So only between 0 to 1 pi, where do I find the solutions? At pi over 6, awesome. And where else? And 5 pi over 6. Okay, that is great. Now, with the help of your partner, not looking back to the first example that I had you write down very little, I want you to write a general rule. How would you find the solutions to this trigonometric equation if we wrote a general rule? recognizing that our trigonometric functions are waves. Go. Why is that wrong? Oh, you can't see that very well. Can't see that very. Sorry, hold on. Why is this wrong? Because a lot of you probably looked at example 1, right? I told you don't look, but you probably looked, and then this is what you wrote down. Why is this wrong? You're really close. Hands up if you think you know. Okay, I think I have 2 people. Turn to your partner. Like, why is this wrong? We're so close. What are we working with again? Tangent. What did I just ask you? So remember, we only have a period length of pi. So how can I adjust this to be correct? X equals pi over 6 plus, any ideas here? N times pi. N allows us to be any integer or any whole number that allows us to see, like, I could say, like, instead of just doing 1 cycle, we want to do 2 cycles and like what it looks like, or 3 cycles, and it gives us a number of solutions based on how many period lengths we want to see. So if I told you, do you guys remember how you used to graph like 3 period lengths? It'd be like, if I gave you this, I don't know if you remember, it's been a while, but you do like 2 cycles to the right and 1 to the left. Do you remember doing that? So there's 3 complete cycles. Well, I could say I want 3 complete cycles or 2 complete cycles, and then you'd list the solutions in that. It's a general rule. Okay, so this is one general rule. Our other one would be x equals 5 pi over 6 plus not 2n pi plus n pi. Before we get started with this, I want us to review about cosine and sine. And so let's actually look right now. Take out our cheat sheet, please. When we look at cosine, how far does it go? It goes how far to the right? All the way to 1 and all the way to -1. Did everybody just hear that? Yes or no? So if I said we had a cosine value of 1.5, does everybody see how that's out of the range? If I have anything between, including -1 to 1, we're good. But anything outside of 1 and outside of -1, it's outside of the range for cosine. Let's look at sine. How high does it go? How low does it go? And it includes those values. So if we get a final solution for sine that's above 1 or below 1, we know it's outside of the range. Keep that in mind. All right, let's move everything to the same side here. So I'm going to subtract 2 cotangent of x, subtract 2 cotangent of x, and I'm going to give both those that are rewatching it and those in class, please press pause. I would like you, with your partner, to only give yourself about 45 seconds to see what you can do with this, recognizing that I'm going to provide you with an example that we are going to factor. Ready? Before I even start on this problem, I want to go back to some basic 7th and 8th grade math that we talked about yesterday. If I provide you with x and y, and I tell you that I'm not going to give you the value of x or the value of y, but I will tell you when you multiply x times y, it equals 0. What could you tell me? What are possibilities for x and y? Go. Which one is 0? X, y, or both, right? Either this is 0, or maybe they both are. We're going to use that same basic concept. So I have cotangent x cosine squared minus 2 cotangent x equals 0, additive inverses. They both contain a cotangent, so cotangent of x equals cosine squared x minus 2. Does that look right? I always want to go back here and check. That's good, and that's good. Okay, this, we're going to apply the same concept. Either this equals 0 or this equals 0. So please take this and set it equal to 0. So take cotangent of x, set it equal to 0, and take cosine squared x minus 2, set it equal to 0, and solve. If you are watching this back, please press pause and complete those 2 steps. Okay, here we go, kiddos. Let's talk about this. So I know that the cotangent is going to equal 0, so cotangent of x equals 0. Now I want to put right now cotangent is equal to 0 over 1. Now this is just how my brain works. Yours may not work like this. I also know what is cotangent. It means the cosine over the sine. On top of that, when I think of cotangent and tangent, how long is the period length? It's pi. So I'm going to make right now a unit circle, and I'm going to go from here to here. Where in this unit circle would I find an ordered pair where the cosine is 0 and the sine is 1? Because that's what this means. Each of our trig functions are simply ratios. So where in the unit circle from 0 all the way to pi would I find this? I'd find it right here, correct? So here's my answer. X equals pi over 2. That's one of my answers. Now I'm going to solve this next one. I have cosine squared x minus 2 equals 0. I'm going to go through this really quickly. Sorry if the handwriting is very messy. 2, we're going to take the square root. We have cosine of x equals plus or minus the square root of 2. All right. Take your phone out, take a calculator out if you have the one that I check out to you at the beginning of the year, and I want you to figure out what is the square root of 2. Come up with a value and round to the nearest tenth. Go. What is the square root of 2? I'm going to give you 20 seconds. Go. About 1.4. Now turn to your partner. How am I able to take these two answers and I cross them out because I can't even consider them? 30 seconds to your partner. Why am I not going to consider those two answers for cosine? Cosine has ranges. Cosine has ranges from what to what? 1 to -1. We include 1 all the way back to -1. Is this outside the range? If I know that this is approximately 1.4, whether it's positive or negative 1.4 is outside the range. Yes, and that's why we exclude it. So we only have one answer, and this is the one answer. We're moving on right now to example number 5. I'll press pause and give you a chance to write it down. This problem, we are going to use our factoring skills in order to find the solutions on the provided interval. Remember, sine and cosine have a period length from 0 to 2 pi. We include 0 and we go all the way up to 2 pi, but not including it. So I look at this and I'm like, okay, that is similar to 2x squared minus x minus 1. And I think I can solve that by factoring. So let's go back here. 2 times -1 is -2. So we have to multiply to get -2 and combine to give us a -1. There are two integers. Those would be 2 and 1, and the 2 has to be negative. They multiply and they combine. So I'm going to come off to the side here, and I'm going to write it down the way many of you preferred learning. So I put this value in, attaching an x, and now I'm going to do factoring by grouping. So I'm going to factor out a 2x. I'm left with x minus 1. Rewrite x minus 1 plus 1. Okay, and when I distribute, I also get the -1. So here we go. This factors into, they each have an x minus 1, and then we have a 2x plus 1. Now, how does that help me with this problem? So I just took these values of 2, -1, and -1, which were the coefficients for the three different terms. And now I can take these two factors, and I'm going to write it out, but I'm going to include a sign. So sine x minus 1 and 2 sine of x plus 1 equals 0. Please take at this time, take each one of those factors or parentheses, set it equal to 0, and solve. Please take each one of these, set it equal to 0, and solve. Go. Now, while you're doing that on your own, I do want to remind you we're working with the sign. So we're looking for solutions from 0 to 2 pi, and our range of answers has to lie within from -1 up to +1. Where does the sine of x equal 1? Anybody? Where is it? I'm hearing different answers. It is Where's the sine equal to 1? Sine is equal to 1 right up here. And what is this? This is pi over 2. So pi over 2 or 1 pi over 2, they're the same thing. And then I'm going to do this one. So I'm going to subtract 1. So sine of x, and I'm going to divide by 2. And I have the sine of x equals negative 1/2. Not positive and negative, just negative 1/2. So I'm making my little circle here. I know sine is the second number, 1, 2, 3, 1, 2, 3. Okay, there's the 1, so this would be 1 over 2. And then I want it, so these would be the locations. And then I'm asking myself, where is the sine equal to negative 1/2? It'd be at these locations. So it would be at, oh, correct me if I'm wrong, 7 pi over 6 and 11 pi over 6. Is everybody comfortable with that? Okay. Check with your partner before I go on. I only have a few examples left. Check with your partner to make sure you're understanding. Okay, when we're solving, we want to have, just ideally, to have one trig function. So I'm going to come over here and ask myself, what can I do here? Well, you know what? I think I could replace sine squared. What is sine squared equal to? It's equal to 1 subtract cosine squared. So let's rewrite this. Sine squared is equivalent to 1 subtract cosine squared. So 1 subtract cosine squared x. Okay, distribute, I get 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. I want you to combine like terms. Do that next, please. Combine like terms. Okay, so now I have, now I have negative 2 cosine squared x plus 3 cosine of x. Now when I move this and combine it with here, I get a negative 1. Is everybody good at that? Now, I never like to, when you think back to things like this is just me. I'm making this up right now. So I don't even know if this is actually, hold on one second. Let's do this one. I gotta think real quick. If I asked you to factor this, I never like to factor when the leading coefficient is negative. Do you agree that if I took this and moved it to the other side, it'd become positive? And if I took this and moved over, it'd become negative? And if I took this and moved it over, it'd become positive. So I'm going to be lazy. I'm not going to write that all out. Change, change, change. I want to know, is it possible to factor this? Try. Is it possible to factor this? Go. Bless you. So it is factorable. I was able to just factor at this point. So what I'm going to do now is I'm going to go back and throw a cosine in there. So I have the cosine x minus 1. And I have 2 cosine x minus 1. Please set each one of these factors equal to 0 right now and solve. Go. We only have one more example after this. Where is the cosine equal to positive 1? Cosine is equal to positive 1 at 0. I'm going to add 1 and divide by 2. Where is the cosine equal to 1/2? right here, right here, right here, and right here. But where is it a positive 1/2? At these two locations. And since cosine is from 0 up to 2 pi, we're going to have these two locations. So I will have the answer of pi over 3, correct me if I'm wrong, and 5 pi over 3. Who agrees with those three solutions? Hands up high. Who agrees with those three solutions? Okay, we're on to our very last example for today. What I need you to recognize is that in this problem, in this particular problem, when we transform this by squaring both sides, we have to account for extraneous solutions. And extraneous solutions means you get all your answers, but then in the end, you got to plug it in to make sure the left side equals the right side. We could do it graphically. We're going to do it algebraically today. So when I look up here, there's no sine squared. There's no cosine squared. So I'm at a loss with how is this going to help me? Like there's no double angle that I can do. There's no square. So what I'm going to do is I'm going to square both sides, as long as I do it to the same to both sides. So let's square both sides. I'm going to square the left, and I'm going to square the right. But in doing that, there is potential. Notice that side. Sorry, guys. There is potential for extraneous solutions. So please write out cotangent of x plus 1. Oh, sorry, cosine, right? Cosine of x plus 1 times cosine of x plus 1, and sine of x equals sine of x. Go ahead, please. I want you to go ahead and factor that out. Now, why is this to our advantage? Because now I can do the front, the inside, the outside last, and this is sine squared. And now I only want to have one trig function. I finally have a square. Would it be smart for me to change the cosine into a sine or the sine into a cosine? Yeah. So I'm going to rewrite this as 1 minus cosine squared x. Okay. When I move the 1 to the opposite side, I'm going to subtract it. So 1 minus 1 cancels out, and then I'm going to add the cosine squared, and I'm adding in the cosine squared. So I have nothing left on the right-hand side. I have 2 cosine squared x plus 2 cosine of x. Please go ahead and factor right now. Factor and solve. So they both have a 2, and they can take out at least one cosine, and I'd be left with cosine of x plus 1. I'm going to set each of these equal to 0. 2 cosine of x equals 0, and cosine of x plus 1 equals 0. By the way, cosine, what is the period length? 2 pi. Okay, we're going to keep that in mind. And what is the range? It has to be in between what? 1 and negative 1, right. Okay, so I'm going to divide by 2, and I have the cosine of x equals 0. Now, where is the cosine equal to 0? The cosine is equal to 0 in which places? At pi over 2 and 3 pi over 2. Okay. So, these are potential answers. I will need to go back and check for extraneous solutions. Then I'm going to subtract 1. And where is the cosine equal to, oops, sorry. Where is the cosine equal to negative 1? The cosine is equal to negative 1 at pi. Okay. So, you ready? We're going to go back right now, and I'm going to come up to the very top, and I'm going to write down these answers. I think pi over 2, my math says 3 pi over 2. Now, because I squared both sides, I've altered the original equation. There is a chance for extraneous solution. So let's check this right now. You ready? What is the cosine? Take out your cheat sheet. We're going to do this quickly. Take out your cheat sheet. What is the cosine of pi? Negative 1. What does negative 1 and positive 1 give you? Okay, the left side has to equal the right side. What is the sine at pi? Does 0 equal 0? Okay, that's an answer. Let's try pi over 2. What is the cosine at pi over 2? 0 plus 1 is 1. And what is the sign at pi over 2? Okay, that works. Let's do 3 pi over 2. What is the cosine at 3 pi over 2? 0. 0 plus 1 is 1. What is the sign at 3 pi over 2? Does 1 equal negative 1? That's an extraneous solution, so we only have 2 answers. Check with your partner to make sure that makes sense to you.